Alright, welcome to the video for the first lesson of unit number 4 on similarity, and in this first lesson in particular, we're talking about scale drawings. So hopefully you have a compass at home. So to do these scale drawings, what we're going to do is we're going to use what we know about our compass to be able to go through and multiply things or make things larger, if you will. So here we have a scale factor of 3, meaning I want to take each of these sides and make them 3 times bigger. So I'm going to start by making one of the points a point that doesn't change. So I'll make point B the point that doesn't change. And I'll start by making an arc at C. If I then pick up my compass and put it on point C and make yet another arc, I've just doubled the size of BC. If I do this one more time, really from anywhere here, I wind up having something that's now 3 times the size. If I take my straight edge and make a line from B all the way to that third arc, that new location is going to be C prime. Now if I go back and do the same thing for AB, since remember we said we're going to leave B where it was, I could open this up, make our first mark, make our second mark, and we'll cross our fingers we have enough room on our paper here. We just about do. Oh shoot, we don't. So luckily for me, I have this wonderful thing called a computer, and I can make all this smaller. So let's see. So we'll group all this up and make it smaller. Hey, now you see it. So then we can go through and make a straight line from B all the way to that new arc. Then I can connect these 2 new points that we had, and we've just made the sides of this 3 times bigger. All of the angles stay the same size, and then we also want to go through and just mark this. We'll call this point C prime, and we'll call this point A prime. Let's look at number 2. Number 2 gives us the same idea here, but we're using a scale factor of a half. Remember, to do a half, we just have to do our perpendicular bisector. So we just have to pick, again, a point that remain unchanged. So I'll make that point A. So if I go through and open this up to more than half or all the way to the end, doesn't really matter either way. So we'll go through and mark that there and do the same thing so that the arcs intersect. I don't really need to make the full arcs. If you want to just make small ones, that works too. And then if I take our straight edge, make a straight line to intersect those 2 intersecting arcs, this would be the new location of B prime. Again, remember we said that we're going to keep A where it was. If I do the same thing again, but for the other line segment AC, so again, open this up so that it's more than half. I like to make the circles a different size. If not, it gets confusing. And again, here I'm just worried about where they intersect. I don't even have to make the full circles if I don't want to. You can if you want. And then if we draw a straight line, I see that they intersect here. Notice a very similar construction. We've done ones like this before, right? When we did the mid-segment theorem, we did this, right? So this should be somewhat familiar to us. And then we have this new triangle, A prime, B prime, C prime. Number 3 is asking us to take this and put it somewhere else with a scale factor of 2. So notice E is going to be the angle that remains unchanged. So again, we'll take our compass. We'll start by using it as a measurement tool. Measure from E to F. And mark that twice from E prime. I'll do the same thing for E to G. and then mark that from E prime as well. 2 times again because it has a scale factor of 2. And again, we're going to go off the screen here, so let me just kind of shift all this stuff down. That works. And then we can draw our straight lines using a straight edge, making sure to stop at that last arc. And I know some of you are going to get a little bit agitated when doing this because all of the questions are so close together and you feel like you don't have room, but you do. Just keep going with it. I apologize, Amaris, if you're watching this. I know you're going to be upset about it. But hey, it's just a homework assignment, right? All right, let's look at 4. 4 is asking us to do the same thing, but making it 1/4 the size. So we did that in class. So notice C and C prime are the point that's going to kind of remain the same. So I want to find 1/4 of CT and 1/4 of CM. So essentially, I'm really just doing some measuring here. So I really don't need to make a ton of marks. I just need to make enough to figure out where the distance is going to be 1/4 of the size. So if we go all the way to T, sorry, I have to make this so small. So if I go all the way to T, make a mark here, and on the other side here, and do the same thing from T. Again, I'm just looking to find the quarter way point, so I don't really need to make all these big circles everywhere. If I use my straight edge, I find the halfway point, which I'll mark. And notice this black line here. I wouldn't even draw that in because I don't really need it. I'm just drawing it in so that I have it, okay? So now I know the halfway point. To find the quarter way point, I need to do the same thing for that new point to C. So again, I really don't need full circles here. I could just do portions of a circle or half circles or whatever you want to do here because they kind of overlap, which again I know is annoying. If I do the same thing from this new point, well, I need to make that one bigger. And do the same thing on the other side. And again, just like before, I don't really need the whole line drawn. I just need to know where that quarter of the way point is going to be. So now if I make that distance, so if I measure that to the quarter way point, I can then measure that here. Heck, we'll even do it in a different color to make it fancy. And now we know where T prime is going to be. So here's T prime. Since the other line is parallel, right, I know that I'm going to have a parallel line here as well, but I'd have to redo all of the same work again for the measurement from C to M. So let's do that. So again, I'll use a different color here. We'll go red. Let me make my line a little bit thinner so that it makes sense. And we'll go halfway. Again, doesn't really matter where these marks are. I'll even just do full circles since I don't think these will be in the way. The first ones I knew were going to be in the way, so we'll do it that way. Oh no. Here we go. Again, we'll use my line. All right, pretend the black line is just a straight edge here. I'm not actually going to write this line down. I'm just interested in where this crosses. So it crosses here. Then I'll get rid of this line. Then I want to cut this in half again. So I want to go here. I need a full semicircle there. That's not in the way, so that's good. And another one there. Use my line again. All right, or your straight edge. And now I know where the quarter of the way point is. It's here. your straight edge. Then if you use your compass again as a measurement tool, see that this segment's a little bit longer than the first one. Not much, it's still kind of little. And I'll make it a purple arc there. And we can call that M prime. So if I connect those points, use purple lines here, right? So I'll connect M prime to F prime, to C prime, to M prime. That little triangle is similar to the original one, just way smaller. Let's look at 5. 5 is similar to what we were doing at the end of the period. I know in some of my classes I got to it, some of them I didn't, so this is a good example here. So we're trying to figure out how much bigger is A, B, or B prime, C prime compared to B, C. So to do that, we'll use our compass tool. So let's measure the distance from B to C somewhat accurately here, and then go from B to C prime and see, well, how many times do we have to go up? So I got 1, 2, 3, 4, and 5. So the scale factor here is going to be 5. So I need to go out 5 for each of the other sides. So if I go from C to A, I'm going to go out 5 little arcs here. 1, 2, 3, 4, 5. And do the same thing from B to C. Or, I'm sorry, B to A. So if I go in this direction, 1, 2, 3, 4. Oh, look, these last two are going to intersect. 5. Where those last two intersect winds up being the point that we're looking for, A prime. If I then use my straight edge, I can connect C prime to A prime. And then back to B prime. Number 6 you could skip. If you're watching this video, you know that. That's awesome. And number 7 is the question I really wanted you to get to. So number 7 tells us that we have a quadrilateral. So number 6 tells us that we have two quadrilaterals. One is similar to the other. So I'm going to start by just drawing two quadrilaterals. Now, to draw a quadrilateral, it really could be any quadrilateral we want. It doesn't necessarily have to be a trapezoid or a rhombus or something. So I'm just going to draw two of them. And I'm just going to make one bigger than the other. If I label our pieces here, so it says that one is a scale drawing of the other. So if I make this G, H, I, and J, and make this A in the same order, B, C, D, I can kind of figure out which of these are true, which are never true, which are sometimes true, etc. So will the length of AB be the same as the length of GH if these are scale drawings of each other? The answer to that is never true. Because if they're scale drawings, one's going to have to be bigger than the other. So since these are corresponding sides, it'd have to be the same exact size. Will ABC, this angle here, be the same as GHI if these are scale drawings? The answer is always true. Because one of the things we know about scale drawings is their angles are preserved. Part C is asking us about proportions. I know we kept saying in class today that the sides of the scale drawings are proportional, but we never actually set up any proportions. So let's look. So AB compares to GH, so AB this side compares to GH this side. And BC this side compares to HI this side. Well, I'm comparing corresponding parts. So those segments should be proportional if this is a scale drawing. So this is another one of those always answers. Is the perimeter going to be equal to the perimeter of the other shape times the scale factor? The answer is yes, always. Because when I'm talking about perimeter, perimeter is talking about the length of the sides. It's not talking about the size of the shape. E says, can the area of the small be equal to R times the area of the big? The answer to that is never. There's something else we're going to do with this R value when we're talking about area, and it's something that we're going to do in a future lesson. We kind of started to talk about it today, right? But you could definitely tell the area of this would not be double, or the area is going to be way bigger. Can a scale factor be less than 0? The answer is also never. If we see a negative R value, that means there's another type of transformation going on at the same time. If we're strictly talking about just dilations or scale drawings, the R value can't be less than 0. Hopefully this helped you understand the problem. Now, if you're somebody that really wanted to do number 6, it's okay. Just know that you're making the shape smaller here, so you have to figure out how much smaller it is to be able to figure out all of the other sides. It's kind of a challenging problem. If you did number 6 and you want to check to see if you did it right, just see me tomorrow and I'll let you know. Hopefully this video helps, and hopefully you're watching these videos to check that you're doing your homework assignments correctly. Have a good night.